So chapter 4 moves on to actual rigid body analysis. And the first thing that we talked about is how to actually compute torque or moments. So here we have a body that consists of like an L-shaped pipe, and we're given the relevant dimensions of the pipe, and we want to compute the moment of the 50 Newton force about zero point 0 in the figure below. So this you can actually use, you can actually compute using the scalar formulation of moments. Note if you extend that line of action of the 50 Newton force out, that the perpendicular distance from O to that line of action is actually the length of this little segment of the pipe, 0.75 meters. So really all that we need to do is pin at O and rotate in the direction of the 50 Newton force. We notice that that's a clockwise rotation, which by convention is negative to us. Then once we've determined the actual direction or sense of the moment, just take the magnitude of the force, or 50 newtons, and multiply that by that perpendicular distance, which is 0.75 meters, and you get negative 37.5 Newton meters, which just says that that force tends to induce clockwise rotation about 0.0. Question 11, I just want to make sure in 3 dimensions that you can compute a cross product. So given the vectors 1, 2, and 0, minus 1, 3, and 0, compute A cross B. If you set up your 3x3 matrix and go and do a cofactor expansion, what you'll find is that the only 2x2 determinant that is not 0 is k hat, and that's not surprising because if you draw these two vectors, they're actually in the xy plane. So when you use the right-hand rule and cross in the xy plane, you would expect that the cross product would only be in the k hat direction. Question 3. Compute the couple moment associated with the 2 kilonewton force pair below. Remember that a pair of forces will actually induce a couple if they're equal magnitude, opposite direction, and separated by some perpendicular distance. So this 2 kilonewton force pair, they have equal magnitude, opposite direction. They're separated by a 0.3 meter separation. If you think about the rotation they cause, it's going to be counterclockwise or positive. Once we know the sign, all that we have to do is multiply by the magnitude of one of the forces, they're both the same, in this case 2 kilonewtons, times the perpendicular distance separating those parallel lines of action, which is 0.3 meters. 2 kilonewtons times 0.3 meters is just going to be 0.6 kilonewton meters, or converted to engineering notation, 600 newton meters. Question 13, find the equivalent force couple system in A in the diagram below. Remember that to find an equivalent force couple system, all that you have to do is add up all of the forces acting on the body. In order to add forces, it's good to decompose them first into rectangular components, which is what I've done here. And then the next thing that you need to do is to compute the moment of each of those forces about point A. That is relatively easy because only the y components of these forces will induce rotation about point A. Because if you look at their horizontal components, those are going to have a line of action that all go through A. So basically all that you're going to do is take the y components of each, find the perpendicular distance, and just be careful with your signs when you compute those moments. So that is it for chapter 4, and I'll see you all in the chapter 5 video.